power factor issues with on-grid solar installations, how to fix reactive power issues with the grid through the PV Genset controller. Usually, low power factor issues arise when grid-tied solar is integrated on a site. We will be exploring and understanding why this problem happens in first place and how to go about them. Hi, I am Shaf Ali from ICSS Engineering. We specialize in solar SCADA and control systems required for safe and productive integration of grid-tied renewable solar energy in existing power infrastructure of industries and commercial applications. Grid-tied solar inverters are meant to work with the grid. Solar inverters are by default set on a power factor of 1. With unity power factor, inverter does not generate or consume reactive power into the power system. Reactive power is induced in the system by the type of capacitive or inductive load running on the facility. As a result, anything that has to do with reactive power is reflected on the primary source. Once solar starts generation into the power system, the active power to reactive power ratio may get disturbed, which drops the power factor on the grid side. An interesting fact is that mostly whenever you buy an inverter, pretty much always you will find its rating in kilowatts, which is active power. On the other hand, if you are exploring diesel or gas generators, its rating is considered in kVAs, which is apparent power. In the case of diesel or gas generators, the power factor is assumed at 0.8. It is just a fancy way to say that generator can handle reactive power up to 20% of its rating. You will be taken aback to know that all grid-tied string inverters can do the same magic. For a region with net metering allowed by the grid, if the distributed domestic, commercial and industrial installation will only be including active power to the grid, the power factor, or you can also refer to as quality of electricity, gets disturbed, especially in peak hours. Loss of quality or poor power factor incur losses to the grid company because of energy wastage, and the balance of power is also impacted. For developed and developing countries, this concern is addressed differently. Grid standards for most developed countries dictate that Power Grid will issue dispatching instructions to the grid-tied solar installation, dispatching instructions to let the grid decide which type of power it wants from the installation and in which magnitude, with ramp up and ramp down timings. This is to ensure a balance of power and optimal dispatch. Ever wondered why almost every grid-tied inverter in the international market has a DRM port in it? The inverter's DRM port is responsible for receiving commands from the dispatcher and generating power accordingly. For developing countries with weak or obsolete grid infrastructure, they charge penalties on the grid electricity bill if consumer drops the power factor below a certain point. Domestic and small commercial consumers are usually waived off from these penalties because electric supply companies have already accounted for such losses in their tariffs. For medium or large commercial or industrial consumers, these fines or surcharges are applied. Power factor or maximum demands are strictly monitored by the grid for every such consumer, even if they have not installed any grid-tied solar in their facility yet. These surcharges become effective if the customer has significant load in ratio to their sanctioned load and the power factor on the grid side gets disturbed for more than a defined period. With grid-tied solar injection started on such a site, the power factor on sink side must be continuously monitored. Power factor improvement panels or capacitor banks reviews or correction may be required to fix the dropping power factor problem. This correction may not be required for sites that have installed comparatively less amount of solar in comparison to the average running load during the day. Actually, to a certain extent, grid-tied inverters can be made to generate or consume reactive power dynamically to correct the power factor on the grid sink side, but the kilowatt hour production may be compromised depending upon how the inverter's power factor is being set by some controller. We usually educate the consumer to correct the power factor through the PFI panel in case of a grid, as investing on PFI once will render more kilowatt hour production from solar inverters. PFI panels or capacitor banks take a long time to weaken anyway. Cluster controllers of certain inverters have dynamic power factor functions built into them. They are measuring the power factor on the sink side and improving it by dispatching commands to the inverters. Usually each grid-tied string solar inverter has a static power factor that you wish the inverter to operate with. Most times in industrial applications, this is not sufficient and dynamic power factor correction is required. PV Genset controllers or PV Genset microgrid controllers must always have these functions built into them.
We have and will be covering more topics related to PV microgrid design, PV Genset controllers, and solar SCADA monitoring. Check out this video's description for the links. You can browse this YouTube channel for PV Genset hybrid projects based on Energy PK PV diesel controller. You can also visit our website www.icssww.com for details. For local and international Energy PK PV diesel controller inquiries, fill in the Google form link provided in the description or contact us through email, call, WhatsApp, email or WeChat. We are glad to offer much required solar operation and maintenance SCADA system called PV SCADA Max. PV SCADA Max is a complete O&M SCADA solution for medium, large or very large scale PV solar integration projects. Salient features of PV SCADA Max are high level of scalability from 100 kilowatt to multiple gigawatts, real-time monitoring of each grid-tied solar inverter and its respective strings, real-time alerts and alarm logs in case of any alarms on inverters, real-time monitoring of energy mix between various sources, for example grid, solar and generators against weather data, transparency of energy generation and consumption reporting, historical trending of parameters, integration of data from third-party SCADA control equipment or process-sensitive instruments, fact-based data for root cause analysis. For local and international Energy PK PV diesel controller inquiries, fill in the Google form link provided in the description or contact us through email, call, WhatsApp, email or WeChat. Thank you for your time. Thank you.